All right, we're talking about angle addition postulate. So that might sound familiar for you because we just did segment addition postulate for 2 days. This is the exact same thing. So the nice thing about today is you're not really learning much new vocabulary. It's really just the same thing. You're just applying what you already know from segments to angles. So it's part plus part equals whole. We need to write that out, but with angles. So our two parts, this is a part, this is a part. These are our two parts. These are my angles. Because remember, an angle is the space in between two rays. So these two parts add together to equal the whole thing. But make sure we know how to name it. Angle AOB. That is not an L. That's an angle symbol. If you look down on 1B down here where I'm pointing, you can see that those are angle symbols. But when I write it, it kind of looks like an L just because it's handwriting. So AOB is one part, BOC is the other part. And then the whole thing is angle AOC. So O is the vertex, so it is in the middle. All right, let's go on to the next one. What I'm going to have you do is I'm going to pause real quick and have you guys write this angle addition postulate. This is the angle addition postulate for this picture. Write the angle addition postulate for this picture. Yeah, all right, so it's JKL plus LKM equals JKM. All right. Yeah, let's continue. So given that JKL is 46 and LKM, yeah, these are just numerical plugging in the numbers. So instead of JKL, I'm going to write 46 plus LKM, I'm going to write 18 equals, okay, what is this random baby M in front of this angle? Can anyone take a gander of figuring out what that M stands for? What do you think, Angel? Measure, yes. You're going to see this a lot this year. So notice it's not up here because there's no numbers in here. We're not talking about the measure, all right? So the measure of angle JKM equals those two added together, which is 64. It's not like the biggest deal. It's not like on a test if you just write angle JKM is 64. I'm not going to take off for that. I just want you to be aware because you're going to see it a lot, and I don't want you to be confused and not know what that means. Okay, and then for this one, LKM, we're looking for JKL. So JKL plus 21 is 88. This is one where we have to subtract, so we subtract 21 on both sides. And then 109 is not right because I just added, but I should have subtracted, so act like that didn't happen. 67, that's better. Angle JKL is 67 degrees. So ABC is the whole thing, so it's part plus part equals whole. So let me write out the angle addition postulate. ABD plus DBC equals angle ABC. And, I mean, for me it helps to write it on the picture. This is 8x plus 20, so I have that visual. This is 22x minus 3. And then the whole thing is 122. So if the whole thing is 122, and then I plug in these other pieces, so ABD is 8x plus 20. DBC is 22x minus 3. And then I combine like terms. Make sure you guys, when you're combining like terms, you're not looking at it and accidentally like subtracting 8 from 22 or something crazy like that. It's all on the same side, equal sign. So combine those like terms. 30x plus 17. Take away 17 from both sides. So you have 30x equals 105. You're going to end up with a decimal on this, but it's okay. We'll stop. It's 3.5. And that's going to go up here. 3.5. Now just make sure that you're able to plug these back in. That is something that you know how to do. You can type it into your calculator, but I've just seen a lot of mistakes on people's work while doing that. So 8 times 3.5 plus 20. That's what we're typing in. 8 times 3.5. Close parentheses. Plus 20 is 48. And then for DBC, which it should be 122 minus 48. So it should be 74. Like, that's what we should get when we plug this in. Because 48 plus 74 is 122, which is that total. So that's one way you can check your answer. 22 times 3.5 minus 3. Ah, yes, it is 74. We did it correctly. Awesome. All right, so if something is the angle bisector, bisector means to what, y'all? Cut in half, right? So these angles are cut in half. So I'm going to put these little arc marks here that show congruence. These angles are cut in half. This angle and this angle are equal to each other. So the angle addition postulate is still part plus part equals whole, even though we know it's a bisector. So AXB plus angle BXC is equal to AXC. So all of them have X in the middle because X is the vertex. All right. This is actually pretty easy, this part right here. We know that AXB is 23. And so it wants us to find BXC. Well, it's the same because they're equal to each other. It also wants us to find the whole thing. In order to do that, it's just 23 plus 23 equals 46. And that's the whole thing. Very easy because of that word bisector. All right, let's move on. So XB is the angle bisector of AXC. So we look at this and we're like, okay, AXB is 5x minus 12. And then BXC is 3x plus 10. And then we don't have the whole thing. So a lot of times we've been setting it up part plus part equals whole. But there's been at least one example on every day of notes so far this week where we have not had the whole thing. And you have the word bisects or bisector, which means cuts in half, meaning each side is the same, each half is the same. So if two halves are the same, you need to set them equal to each other. So you need to take the two parts and set them equal to each other because of that word bisector. You can set them equal. 5x minus 12 equals 3x plus 10. And then you can solve. So minus 3x on both sides, subtracted on both sides, I guess. 2x minus 12 equals 10. So I subtracted 3x on both sides, I added 12 on both sides, and then divide by 2. So x is 11, but it wants the measure of angle AXC. So what I'm going to choose to do is take 11 and plug it into just one of them. It doesn't matter. One way to check your answer is to plug it into both of them and make sure they're equal. That is a good way to check it. But so like this one's 43. The other one should also be 43. 5 times 11 minus 12 is also 43. But if each half is 43 degrees, then the whole thing is going to be 86. AXC, that's the whole thing. So you just have to plug it back in and double it, or plug it into each one just to make sure you have it correct, and add them together. All right, last problem. Moving right along. Alright, this picture will have to be like slightly guesstimated. You can't really draw it to scale. I mean, I guess you could. But what I'm going to do is draw a straight line, because supplementary angles, if you can see on that tiny little picture over there, the one on the bottom left-hand corner of that supplementary, see how it's on a straight line? Angles on a straight line, two angles that add up to 180 on a straight line are always going to be supplementary, because the straight angles are 180 degrees. So if you split it into two, they're going to add to 180. So I'm going to draw something like this. There's a bigger angle and a smaller angle. The one that's bigger is the one with 6x. The one that's smaller is the one with 3x. R is going to be the vertex, because R is that middle letter. And then they share Q. So Q has to be on that shared line. So that's how I'm determining how to draw that. They both share Q. And then the bigger angle has P, the smaller angle has S. So that's how you know how P goes here and S goes here. But, I mean, you should be able to draw this just based on those words right there. Knowing that it's supplementary, so you need a straight line. And then based on where's the vertex, what's the shared point, and what's the point that is completely separate from both. All right, so we've got 6x plus 13, and we have 3x minus 4. So we can set these equal to 180 degrees because of the word supplementary, meaning equals 180. And we can add them together. 6x plus 13 plus 3x minus 4 equals 180. So 9x plus 7 equals 180. Not 7, that should be 9x plus 9. We're going to subtract 9 on both sides. 9x equals 171. So I think x is 19. Is that what y'all are getting? Nice. So x is going to be 19, and we just have to plug it in to these two. 6 times 19 plus 13. Need to close those parentheses. Is 127. So if we did this right, this one's going to be 53. If we did it wrong, it's going to, oh, not 54. 53. If we did it wrong, 3 times, nope, 19. Minus 4. Yay, it's 53. Okay, we did it right. So these are our final answers.